The first type of proof that we're going to go over is a flow proof. A flow proof is when I need to give you evidence that I can rap well. Oh boy. No, I'm kidding. A flow proof is like a flow chart, but with, proof and stuff. So let's take a look at what we have. Given the triangle pictured, I need to prove that x equals -8. So, all right. So let's start out with what I have. I have in my box, I have triangle, triangle. I don't even have a name for it. I'm just going to say triangle pictured. Triangle pictured. All right. And my reason for that is the given. You always put your given in the first box. What do I know? I know that if it's a triangle, I know that 65 plus 40 plus x plus 83 equals 180. How do I know that? Well, I know that because of the definition of a triangle. Or we could also say there's a little thing called triangle angle sum. Again, if this was a test and if I were to give you a pop quiz on this and ask you to explain what you did, I wouldn't expect everybody to pull out the fact that there's something called the triangle angle sum. It's also called the interior angle sum. All I know is I would expect you to show, you would do this the way you would do a regular math problem. The way you would do a regular math problem is you would say that plus that plus that equals 180. Now you're just explaining yourself and you're putting them in boxes. All right, the next box that I can create is the fact that I have 65 plus 40, which is 105, plus 83, which is 188. 188 plus x equals 180. How did I do that? Well, I combined like terms. Now I'm going to take my chart and I'm going to bring it over here because I like to work left to right. Not that that's what you have to do, but that's just what I'm going to do. And what I'm going to do is I'm going to subtract 188 from both sides. So I'm going to write out the original thing, and I'm going to subtract 188 from both sides. When you subtract a number from both sides of the equal sign, it's called the subtraction property of equality. No matter what I do, it's going to be kind of blurry on the side. That's a bit blurry. That's better. When you do that, you get x equals -8. And I do that by combining like terms again. So I'm done. I mean, my job was to prove that x equals -8, and I did. I did it. I did just that. And a flow chart or a flow proof is the same thing as making a flow chart with explanations along the way. Okay. I'm just letting that sit there, let it marinate for a minute before I go to my next flow proof. Make a flow proof. I've heard of foolproof, but flow proof, that's different. Boy, am I good. I'm on fire today. I'm on fire. Someone call the fire department because I'm roasting here. Oh, man. Given M is the midpoint of AB, segment AB, AM equals 2x plus 4, and MB equals, there's a lot there. So I have a lot to pack into my given box. So I have M is the midpoint of AB. I also know that AM is 2x plus 4. I also know that MB is 4x minus 2. I also know that AB is 20. Huh, that's funny. I only have 6 of those. So that's what I have. That's the information that I have. I should be able to look up at my picture and say, all right, well, look, if M is the midpoint, then I know that AM and MB are going to be equal to each other. So that's what I'm going to say next. I'm going to say that AM is equal. Oh, you know what I forgot to do? I forgot to say given. Oh, boy. I know that AM is equal to MB. Now, there's 2 different ways that I could have done this, and this is just the first thing that I did. The 2 different ways that I could have done this is I know that if AM equals MB, then I set these guys equal to each other. That's the one thing I could have done. The other thing that I could have done is AM plus MB equals 20. So there's 2 different ways that I could prove that X is 3, but this is what I'm doing, and I'm sticking with it. So the reason why I could say that AM equals MB is that's the definition of a midpoint. A definition of a midpoint says that if you have a point that is in the middle of a segment, it cuts that segment into 2 equal parts. And by M being the midpoint, it cuts AB into 2 equal parts. So what I can do now that I've said this is I can say that if AM equals MB, I could say that AM is 2x plus 4. That's going to equal MB, which is 4x minus 2. Why am I allowed to do that? Because I substituted, and this is called the substitution property of equality. If I replace something with something else, it's called the substitution property of equality. This all goes from those rules that were written down that I'm taking it from. So like that's why I said subtraction up here that you can't see anymore. All right, so what can I do now? Well, if 2x plus 4 equals 4x plus 2, I can get rid of, let's do 2x from both sides. So what I'm going to do is I'm going to subtract 2x from both sides. By doing that, I employed the subtraction property of equality. That makes it become 4 equals 4x minus 2. How do I know that? Well, because if I take what I said was 4 equals 2x minus 2. How do I know that? Well, if I take 4x minus 2x and combine those like terms, I end up with that. So allow me to write out this guy again. 4 equals 2x minus 2. And in order to get x all by itself, I add 2 to both sides. What is that called? the addition property of equality. Addition property of equality says I can take any number and add it to both sides of an equal sign. When I combine like terms, I end up with 4 equals 2x. I keep doing that. 6 equals 2x. 6 equals 2x. And I did that by combining like terms. Oof. Let's keep flowing. Let's keep flowing. If I take 6 equals 2x and divide both sides by 2, I'm doing what's called, sorry about that, I'm doing what's called the division property of equality. Didn't give myself a whole lot of space to do this problem. Shame on me. That becomes 3 equals x. Why? Because I combined like terms. And did I prove what I wanted to prove? Yes, but no. I have 3 equals x, which I'm allowed to turn into x equals 3 because of the reflexive property. Float proofs are not fun at all, unless you have a sick brain and there's something wrong with your brain. But there it is. It's a challenge, and it's just a way for me to explain what I'm doing. But the long and short of it is I'm just looking at everything. If I take my fact that I have up here, right, and I just show all of my steps and explain what I'm doing, that's what a flow chart is. Great. Now that I feel comfortable about that, let's do something new. Not new, but something that you've seen before. This is probably the worst of the two. The paragraph proof. Given that M is the midpoint of PQ, write a paragraph proof to show that PM equals MQ. Okay, well, what am I given? I am given, and that's how I start a paragraph proof out. I write out what my given is. I am given M is the midpoint of segment PQ. And what I have to do is I have to prove that PM, post meridian, equals MQ. All right. So I don't know why I started out with so. If M is the midpoint of PQ, then PM is equal to MQ by definition of a midpoint. Segment PM is congruent to segment MQ because line segments that are equal in measure are congruent. That's it. It seems too obvious. It seems too easy. But sometimes that's what paragraph proofs are. Paragraph proofs are like, hey, I'm going to give you this, and you need to show me that. Well, you could be like, well, if M's the midpoint, then that means these two guys are equal to each other. And if they're equal to each other, then they're congruent to each other. Done. That's it. That's it. Let's take a look at one more. It's hard for me to see that. Given that angle BA, I'm sorry, not angle, that line BA is perpendicular to line BC. Okay, is it line? It's actually ray. Given that ray BA is perpendicular to ray BC, prove angle 3 and 4 are complementary. Okay? So I have the given. Let me just write it larger so you can see it. I'm given the fact that BA is perpendicular to BC. Now, usually, and I remember a couple weeks ago, somebody saw that sign and said, what does that sign mean? It's perpendicular. Okay, so now I actually get to really explain what it means. I need to prove angle 3 and angle 4 are complementary. So I need to use words to prove that. All right, well, by definition of perpendicular, then BA and BC, and I'm going to make those line segments, BA and BC intersect to form 90-degree angles, or a 90-degree angle. Angle ABD plus angle DBC equal angle ABC. Because they share a common side. So this is what I'm doing. This is how my brain works. I just showed that that angle and that angle intersect to make 90 degrees. I'm saying that that guy and that guy adds up to 90 degrees. Well, adds up to something. Adds up to ABC. Angle ABC is 90 degrees because they are created by BA and BC. So now what I'm doing is, this is what I said so far, these two intersect to make 90 degrees. These two angles right here add up to each other, or add up to ABC, and ABC is 90 degrees. So by substitution, angle ABD plus angle DBC, angle ADB plus angle DBC is going to equal ABC. Nope, ABC is 90 degrees, so equals 90 degrees. Also, angle, what is it? 3 plus angle 4 equals 90 degrees by substitution. What does that mean? Angle ABD is 3. So I'm turning ABD into 3. Angle DBC is 4. So I'm turning DBC into 4. So if angle 3 and angle 4 are 90 degrees, then by the definition of complementary, angles, angle 3 and angle 4 are complementary, because complementary is 90 degrees. Who would have thought that when you guys were like really smart and were able to be advanced and stuff like that, that you would be involved in a math class that involved a whole lot more writing than math? Oh, well, that's a mess. But that's how paragraph proofs are. Paragraph proofs are just ways that you can use a paragraph to describe the steps and the motions of a proof, if you will. So that's it.